Okay guys, so what we're going to be talking about here is we're going to take just a quick break on finding the derivative, and we will come back to that in a little while. And instead what we're going to use is this is going to kind of solidify what it is that we've been talking about as far as what the derivative tells us. So this is kind of an activity that we did in class. If that doesn't make sense, I'll explain kind of what's going on here, and hopefully it will make sense to you as we go through it. Okay, so to start off with, I'd like to say what we're going to do is we've got this graph right here. Okay, this is just some polynomial function. I don't know what it is. But on this polynomial function, what I'm asking you to do is I'm asking you to draw two separate tangent lines when x is basically less than -2. And you can draw them wherever you want, and my tangent lines are not drawn very well there. And then in the activity, what you're asked to do is you are asked, once those tangent lines are drawn, and I drew very, very poor ones here, but the question is, what do those two tangent lines have in common? And you could say a lot of different things about it, but the main thing that you'd want to say about it is that I look at those and I say, okay, wherever you chose them, and you didn't have to choose them in the same place that I did, but wherever you chose to draw those tangent lines, both of them had a negative slope. And so this is an important idea. I know right now it doesn't make a whole lot of sense what's going on, but right now, just kind of stay with me. Both of those have a negative slope that I drew. If I were to ask you something similar, and I know that's cut off on your screen, but it says draw two tangent lines on the interval from 1 to 0. So now we're talking about this interval over here and drawing two more tangent lines. So if I were to draw a tangent line maybe there, and maybe I'm drawing a second one like right there, what I could say about those is that both of those tangent lines had a positive slope this time, regardless of where I was, all the way from +1 all the way to infinity. Wherever I drew a tangent line, it would have a slope of a positive number. I don't know what that slope would be. I have no idea what this function is, so I couldn't do all the things that we did in the previous two lessons, but I would know that both of those have a positive slope. If I was to look between -1 and 1, so x equals -1 is right there, x equals +1 is right there, and I were to draw a tangent line on one of those points, a point somewhere between those two x values, the first thing you might notice, you're like, wait a minute, is that still a tangent line? Because if I extend that thing out, it's going to cross the graph in like another two places. Well, yes, that still is a tangent line because we only chose one point, and it just so happens as we get away from that point that it crosses the graph in other places, but that is still considered to be a tangent line. Now back to what we're talking about here. You'll notice that the slope of that line from -1 to 1, anywhere between -1 to 1, is also has a negative slope. We don't know what it is, but anywhere between -1 and 1 that we look at this function, if I were to draw a tangent line, it would have a slope of a negative number. So what that has in common with the tangent lines anywhere that we drew from -infinity to -2 is that those have a negative slope as well. And hopefully you're kind of seeing where the connection is going to be made here in a second. If I look between x equals -2 and -1, so just right here, this little short distance right here, if I were to draw a tangent line right there as well, I would see that that tangent line has a positive slope. And what that has in common with all of these slopes that I drew over here between 1 and infinity is they also had a positive slope. Now you might be asking, why are we drawing tangent lines on somewhere on these different intervals? Okay, well, let's look at one more. You'll notice this last one says draw tangent lines at all the following, at x equals -2, at x equals -1, and x equals +1. If that's the case, hopefully you can see that all of those tangent lines would have a slope of 0. And this is what's true, and I chose those points specifically to show you that anywhere our function has a turning point, and as a quick review, a turning point is just where the function changes from increasing to decreasing or vice versa, then if I were to draw a tangent line at those points, so any one of these 3 points right here, these x values, if I were to draw my tangent line at those points, they would have a slope of 0. Okay? Again, we haven't said why we're doing this yet, but hopefully that makes sense as well. Now, each of those values, and we will deal with this more later, are called critical points, and we already talked about why they're called critical points, because those are the only points on the graph where we change from increasing to decreasing or vice versa. So when you look at these different functions, you can be like, oh, okay, they're called critical points because that's where the graph changes from increasing to decreasing. And now you have an additional definition. That is where the slope of the tangent line if we were to draw a tangent line at that point, would be 0. Now you might be saying, okay, why did you just do that? That was 5 minutes, that was an exercise, I could do all those things, but why did we talk about that? Well, here's why we talked about it. This is a graph of my original function. If I, for some reason, and there are a lot of reasons you'd want to do this, if I, for some reason, wanted to know what my derivative looked like, we talked about how to find it over the last couple days, how to find the derivative, how it gives us the slope of the tangent line. But if you think about it real quick, like if I had this function, okay, let's say I had like x squared. Here's x squared right there. The derivative of x squared is 2x. And that graph looks like that. And so when I look at how these two are related to each other, they are related, okay? And this is something that some people struggle with a little bit as far as trying to figure out what the graph of the derivative looks like if you don't have a graph of the original function. So here's what we do when we're trying to figure out what the graph of the derivative looks like. The first thing that we do is we say, okay, where are my turning points? At what x values do I have my turning points? And in this case, that's at x equals -2, -1, and +1. Now, the reason for that is because at those points, my derivative, my slope of my tangent line is going to be 0. What that means is when I graph my derivative, my y value is going to be 0 as well, because the derivative is simply a representation of the slope of the tangent line. Now, if I was looking anywhere between -∞ and -2, this function is always decreasing, which means the slope of the tangent line is always negative, and we talked about that earlier. What that means, however, is that my derivative graph will always be below the x-axis. So not only will it always be below the x-axis because my function is decreasing on that interval, but it has to cross through this point that we've got right here, this x equals -2. It has to cross through the y-axis there because that's where the slope of the tangent line is 0. Then, as we move from left to right, from -2 to -1, my graph is increasing, which means the slope of my tangent line would be positive there. So if the slope of my tangent line is positive there, that means my derivative graph must be above the x-axis. Now you'll notice I didn't go very far above the x-axis, because yes, it goes above the x-axis, but it has to cross through the point -1, 0, because I know the slope of my tangent line at -1 is 0. Then what we do is we say, okay, from -1 to +1, my function is decreasing again, so it's going to be below the x-axis. Now, the question always comes up, how do I know how far to make my graph go below the x-axis before I bring it back up and make it cross through again? And we're going to get to that in just a second, and I'll explain that because there's an activity that goes with this that we'll get to in just a sec. But know that there is a way, and you guys will practice doing that. Then you'll notice from 1 to infinity and forever on, the graph is increasing, which means my derivative is going to be above the x-axis. So a general rule that we can use is that if the original function, so we'll call this f of x, is increasing, then f prime of x will be located above the x-axis, because that means that my derivative is positive. If f of x is decreasing as we move from left to right, that means that f prime of x will be below the x-axis. And if f of x has a turning point, then we know that f prime of x is on the x-axis. So anytime the slope is 0, then my derivative would be on the x-axis. Now you might be saying, okay, that's great. How do I do to figure this out? Because that kind of makes sense, but there's a lot that I still have to do with that. And so in order to do that, what you're going to do is you're going to go into Canvas, and from Canvas you are going to go into this section and you'll click on a link and it'll take you to a screen that looks like this. Okay, and you'll have to activate Flash on your computer. Now what this is a program that allows you to draw the derivative. And so what we're going to do, this function that is on top is our original function, and we are going to draw the derivative, and all you do is you take your mouse and you just click and you draw, and it'll draw whatever function you want. You can go back and fix it. So if I want this graph to go up here instead, I just kind of pull it and I go up there. And it makes a different graph. And so what we'll do is we'll try and draw our derivative based on the original graph. And so what we would say, for example, here is, notice this function is decreasing to start. What that means is my derivative function would have to be below the x-axis. And then about right there, so a little bit after negative 0.5, I can see that my function is going to cross the x-axis about, it'll be about right there. So maybe my derivative looks something like that. Now again, you might be asking, how do I figure out how far away to make it? And that's just, we'll get to that in just a second. Notice from negative 0.5 basically all the way over to 1, my function is increasing. So I'm going to bring my derivative graph up, and then I'm going to bring it back down to about that point. Then my original function is decreasing from 1 to about 2.5. So that means my derivative graph has to be below the x-axis for that entire time. Whoops, I drew that kind of poorly. So there we go. That looks a little bit better. And then from 2.5 on, my function is increasing. So I would say, okay, that's going to go above the x-axis, something like that. Now, that's not a perfect drawing what the derivative is, but what you do once you get a guess as to what your derivative is you say, okay, check answer. How close was I? And you'll notice that my derivative, for example, I went a little too high on this part right here. Like my derivative graph looked good as far as where it's located above and below the x-axis, but I went too high. And I went too low, and then this one was actually pretty good. Your goal when you do this, and it's your homework for this assignment, is you're going to do, what you want to do is you want to get the signs portion to be 95% and the accuracy to be 90%. Now you might be saying, okay, well, how do I do that? Well, all I do is I click new function, and it gives me a different function. Now, this is a new function. This isn't the same function, so I can't just try and repeat over and over, because I can get it every time I want a new function. I can just hit new, and it will give me a new function to look at. And so that's your homework, and the more times you do it, the more you'll realize how far you need to pull your graph above or below the x-axis when you draw your derivative. So hopefully that makes sense, guys. Hopefully you can see what you're doing there. If you have any questions about this, please let me know. Otherwise, good luck, and if you have any questions, come ask.